Shall we start, Professor, or we will wait for 5 to 10 minutes?
It's okay. You can go according to your planning, huh? I can see.
Okay, sir. Now the 65 participants are joining. So I think one by one they will join, sir. So shall we start session, sir?
Yeah, sure. Yes.
Okay.
Yes,
Madam, Sudha, madam.
Okay, sir. Always believe that something wonderful is about to happen. A very happy and pleasant morning to everyone present here. I must thank each and every one of you for being here with us today on this blessed Sunday morning. It is my great pleasure to welcome you all on the behalf of SRM Institute of Science and Technology for Day 7, 2 weeks online international faculty development program on the era of change, a recent advancement of machine learning in terms of AI and IoT, organized by the Department of Computer Science and Application. Now, I would like to invite our respectful Vice Principal Admin SNH, Dr. J. Dileepan, to deliver the welcome address. Please, sir.
Good morning, madam. A very warm good morning to one and all. I am very happy to welcome to you all to this day 7 of this 2 weeks online international faculty development program. It is my great pleasure and privilege for me to welcome our chief guest, Dr. Tediva Elisa Namasiswa, lecturer, head of postgraduate program, information technology, Infrastructure University, Kuala Lumpur, Malaysia. Thank you, Professor, for accepting our invitation. The topic of the today's session is information security challenges in the era of open networks and IoT. So presently, IoT refers to a concept of connected objects and devices of all types over the internet, either wired or wireless. And it has increased rapidly as these technologies are used for various purposes, including communication, transportation, education, and business development. So the IoT has some challenges and security risk. So according to the challenges, the improper device update, lack of efficient and robust security protocols, user awareness, and famous active device monitoring are among the challenges of IoT. The top risks are lack of compliance on part of IoT manufacturers, lack of user knowledge and awareness, and IoT security problems in device update management and botnet attacks, etc. And hope the today's session will be an eye-opening session for all the participants. And our chief guest will explain about this very clearly. So once again, I welcome you all to this wonderful session. Thank you.
Thank you, sir. Now, I would like to invite Mrs. D. Kanchana, Assistant Professor, MCA, to introduce our chief guest.
Very good morning to one and all present here. It is my privilege to read the profile of today's chief guest, Dr. Tadeva Elisa. Is a lecturer in the Faculty of Engineering, Science and Technology, Department of Computer Science and Networking at Infrastructure University, Kuala Lumpur, Malaysia. He is also the head of postgraduate program for a Doctor of Philosophy in Information Technology, Master of Information Technology and Master of Information Science at the Center for Postgraduate Studies in IUKL. He is responsible for the development, implementation and maintenance of content for all his modules. Tadeva Elisa joined Infrastructure University, Kuala Lumpur as the first international student in 2003, where he pursued his IT as a diploma in information student and later as a Bachelor of Information Technology student majoring in network technology. Later, he is to spend 8 years of University Technology, Patrons, where he worked as research assistant in the Advanced Electromagnetic Laboratory. During this time, he developed a wavelet-based computer algorithm for analysis of big data from seabed logs collected using the novel antenna. His contribution were to later earn his PhD in IT for developing big data analysis computer algorithms. Before pursuing his PhD, during his time at University Patrons, he attained Master of Science in Information Technology. His research was on computer network security algorithms for wireless sensor networks. His research work earned him a patent and International Award of Excellence, which includes Gold Medal from British Invention Society, Geneva Invention, Seoul International Invention at Korea, and International Invention and Innovation Exhibition ITEX in Malaysia, among many honors he received. And he rejoined IUKL from Patrons in 2017. He teaches IT networking related modules as well as supervised PhD and master in IT research candidate. He is currently pursuing supervising 6 PhD candidate and has graduated more than 8 master's candidate to date. His research interest in computer algorithm development, computer and information security, big data analysis, and education governance. We welcome you, sir, once again. Sir, now the forum is yours.
Thank you. Thank you so much for the introduction. Again, my name is Tadiwa Elisha. I am speaking to you today from Malaysia, where I am engaged with Infrastructure University Kuala Lumpur as a lecturer, as just has been introduced. Today, I'm going to be speaking to you on the information security challenges in the era of open networks and IoT. I would have loved to ask for more time or even another session to talk about this issue of security challenges because it is a very broad area which affects us from different angles and different dimensions of our time today. And as you can see at the bottom of my first slide, this is a never closing gap and a never ending war. So the approach I'm going to give today for my talk is I'm going to start from a very, very broad and wide perspective of where we are coming from until I get to the heart of my talk towards the end of this talk. I thought so because most people, we are coming from different walks of life, and our experiences are not exactly the same. When we are talking of information security, it can be a very highly technical area. So I try to simplify it and try to bring in the why do we need this information security? Where are we going? What are the challenges? Maybe what are the probable solutions? And why is this a never closing gap and a war which we think that it might not end? So as has been given in my introduction, this is my name and my email address at the bottom there. For those who want to contact me after this and have some discussions, share some ideas, or if you have some questions, you can get me at tadiwa.elisha@iukl.edu.my. All right. So to kickstart my talk today, I want to talk about the gap. The gap is a measure which has been used since the beginning of time. It has been used to differentiate, classify, identify, and even quantify things. And some of the gaps are natural, while some of the gaps are man-made. Some gaps will forever be there, and some will widen as some close. The biggest example or the easiest example I can give of the gap which everyone is aware of is on our Earth's history, where if we go back 2 million years ago, the whole Earth was like one solid mass surrounded by water. And with time, as time moves on, we went on to the period of the Gondwana land, where the gaps between the continents of the world started to increase and the differences started to appear. If we look at the present day today, the gaps are well defined. The gaps are well defined, and these gaps are now being used to qualify, to quantify, to identify, and to classify things. Like for me, I am African simply because of where I come from. I come from Africa, and the gaps which are between Africa and Asia are used to differentiate between Africans and Asians. If these gaps did not exist, then it was not going to be possible for us to do those classifications, those identifications, and so on and so forth. So this concept of gaps, they apply to all walks of life until we move on to today, the challenges we have in our everyday presentations and everyday life. They are based on the existence of gaps. So in a nutshell, a gap is a break or a hole in an object between two objects, a space or an interval or a break in continuity. This is very important because now we are going to look, I'm talking of the problems we are facing in security. So these problems are gaps which needs to be filled in the information security or in the technology area. So that's why I'm coming in from giving a definition of a gap so that we can move along together. So in the education circles, we always talk about research gaps when we are doing our studies. We have to look for that research gap. We have to identify the research gap. Until and unless we have a proper research gap, then only we can go on and have our research. So in those areas of in the academic circles, a research gap is defined as a topic or an area for which missing or insufficient information limits the ability to reach a conclusion for a question. All right, so this is in the academic circles. So what are we looking for when we have a gap? We are looking for the bridge, we are looking for a connection. So normally the bridge provides a connection, it provides a contact, it provides a transition from one end to another end. So in today's networking, in today's community, internet community, we have this gap, and we are trying to find the bridge to close the gap. And as we approach towards the solution, as we approach the feasible solution or a well-designed bridge, the gap widens again, and we have to think of new methods, new ways of closing that gap. That is the biggest challenge we have. So the challenges we face in technology today, especially in when it comes to security, they are challenges which affects everyone from all walks of life, every day of our life, and no matter who you are, where you are from, these challenges, you will face them at one point of your time. When we look at these challenges now, we have organizations such as the United Nations, which have come up with the United Nations Sustainable Development Goals with a vision to close these gaps which are identified in these visions by the year 2030. So they come up with 17 goals. For me, I call them gaps. I want to refer to them as gaps because we have gaps in poverty, hunger, health, education, gender equality, water and sanitation. We have gaps in life on land, peace and justice, and we have gaps in all the 17 identified areas. So these are the common areas where we have all those gaps. So what is our main challenge? Our main challenge is to identify the gaps in these areas, identify their depth, and identify the breadth. Just like when we have a physical gap on Earth, we want to close that gap, we have to build a bridge. Maybe it's a river or it's a valley or something. We have to build a bridge to eliminate the effect of that gap. So when we want to build the bridge, we have to have a thorough analysis of the depth of the ravine, the breadth of the ravine, so that we can come up with the solid solution which can address that gap. We have to do it as fast as possible before the gap becomes even bigger. All right. So analysis of the gap has to be properly and thoroughly done to determine the correct and most efficient way of closing or reducing or filling the gap. In most cases, we cannot fill the gap. We try by all means to reduce the gap. When we look at things like poverty, when we look at things like hunger, when we look at things like health, we really cannot say that we can close the gap, but we can reduce the gap and make the lives of the people easier. All right. So given these challenges which have been identified and given to us, well summarized by the United Nations as Sustainable Development Goals, our challenge as people in academics is to find the solution. Now, what can be the solution? Can technology be part of that solution? For us to answer this question, we have to understand what is technology first. Okay, so I started by looking at the gap at a broad perspective. Now I'm looking at the solution to close the gap. There are so many solutions out there, but me coming from the technology background, I'm looking at technology as part of the solution to close those gaps which are available out there. So we have technology as one of the mechanisms or the machineries which can be used to close that gap. But we need to understand what is technology. There are so many definitions of technology. When I was looking at it, I become so overwhelmed by the number of definitions of technologies which I can get. But I thought these four, they give a complete, wholesome picture of what technology is all about. The first definition is telling us technology is a branch of knowledge that leads with the creation and use of technical means and their interrelation with life, society, and the environment, drawing upon such subjects as industrial arts, engineering, applied sciences, and pure sciences. So when we look at this definition, I always tell people that technology is everything because there is nothing which has been left here. We are talking about life, we are talking about society, we are talking about environment, and we are looking at subjects in industrial arts, engineering, applied science, and pure sciences. So everything we think about, be it from the academic perspective, from the social perspective, it is covered within the term of technology. All right. Some people would say technology is the sum of techniques, skills, methods, and processes used in the production of goods or services, or in the accomplishment of objectives such as scientific investigation. That is the other branch of, or the other way of looking at technology. All right. So as I said, there are so many. The most interesting one, which has touched my my attention, will be the first definition of technology. Now, let's look at how can technology be the solution. For how long has have we depended on technology as a solution to societal, environmental, to life problems, and whether we are coming from the arts, we're coming from engineering, we're coming from the sciences. How long have we been dependent on our technology as a solution? It began with the Industrial Revolution 1.0, 1784, mechanization, steam power, and weaving loom in UK. Yeah? So the UK was the center for Industrial Revolution, for the Industrial Revolution 1.0, Industry 1.0. So what was the basis? What was the push? What was the drive behind Industry 1.0? Was technology, where there were vast changes, too much changes in mechanization, steam power, which brought in usage of high-powered machines and or the weaving loom. And then after that period of the first industrial revolution in 1870, humanity witnessed the second Industrial Revolution 2.0, where mass production, assembly lines, and electrical energy came into being. Wow. So that's brought in a totally different perspective of technology as a solution to mankind problems in 1870. So electricity, it changed the way everything was being done, and it has shaped the way humanity looks at itself until today. We went on to 1969, Industry 3.0, where we have automation, computers, and electronics, right? So this revolution, Industrial Revolution 3.0 and Industry 4.0, they are the ones which we, this current generation of people, we have contributed, we are contributing towards, and we are really practically experiencing and seeing how the difference from one revolution is moving to another revolution. With the advent of Industry 4.0, which is today, we have cyber physical systems, Internet of Things, and networks, which brings the importance of today's topic: cyber physical systems, Internet of Things, and networks. It is a technological solution to the problems which we have, to the gap which has been identified within humanity, that we need to close this gap so that we can appreciate, or we can look at production of things, how we do things in a totally different perspective. The Industry 1.0, it was very powerful, yes, but during that time, now we have Industry 4.0. Now, if we look, the one perspective which I want to highlight here is the years, the time between the industry revolutions. So we have 1784 to 1870. That is the gap between the first and the second industry revolutions. And then we move to the second, which is the 1870 to 1969, and then from 1969 to today, the gap is getting smaller and smaller and smaller. But if we look at the impact to society is becoming, some would argue that the impact is becoming more. The time which is taken to come up or to introduce or to experience or the time for the need of another revolution is becoming shorter and shorter and shorter, while the impact of the revolutions are becoming bigger and bigger and bigger. All right. So with these solutions, these industrial revolutions, with these technological advancements in cyber-physical systems, Internet of Things, and networks, there are a lot of good things which come in, and so as challenges, a lot of challenges which come. So the good things are actually helping or contributing towards the closing of the gap, while the challenges are widening the gap. So we have to make sure that the good harvest we get from, or the positives, the advantages we get from the solutions which we are giving, they are greater than the disadvantages. Otherwise, the gap is going to become more. We have to close the gap. Even if it widens, it must not widen as much as it has been closed. Then we can say we are moving forward. So I just want to take time to look at the results of the major technological breakthroughs which we have had so far because of the Industry 4.0 and the Internet of Things and networks. We have to appreciate what we have. We are looking at the positives right now. So we are looking at what gaps have been closed and how much have they been closed before we look at the problems which we are facing right now. So I have identified, some will agree, some will not agree with me, 10 the most visible or most valuable contributions which have been brought in by technological breakthroughs, the major technological breakthroughs in the recent times. So we have organ transplants, where we now humans we can transplant human parts from one human being to another human being. If I have a heart problem today, it's no longer a death warrant that I'm going to die because of technological advancement. There are now chances that hearts can be transplanted from other human beings who are no longer able to use the hearts to the best of their their lives or whatever, because of accidents and whatever. And other human beings have got problems with their hearts, they can be transplanted. And we have technology-based implants which can be put in to substitute the functionalities of organs such as the heart, the eyes, our breathing, kidneys, our skin, vascular tissue transplants. We have all other major body functionalities. They can be now addressed from the technological point of view. This is an advancement which is brought in by technology to close in the gap. We have robots and artificial intelligence. Who would argue that robots and artificial intelligence have not contributed to a rapid change in the way we look at things and the way we do things? At the beginning, many of us would have appreciated artificial intelligence and robots, and those who would fight would say that robots cannot replace humanity and so on and so forth. They are going to take our jobs. They are going to redefine what a human being is. But with time, we suddenly starting to appreciate the inclusion of robots in the part of humanity. That is also a contribution and a closing of the gap which has been brought in by the advancement in technology. We have electronic funds transfer where we don't need to go and queue in the banks today. We need to, before that, we need to go to the bank, queue, take the money, go and buy, exchange money and all this. These days, paper money is no longer as valuable as it used to be, because now we are all using electronic funds, electronic funds transfer to make all our payments, our shopping, and so on and so forth. That is a major technological breakthrough. All these breakthroughs I'm talking about, they have problems which we are going to talk about later, which are the main problems, the main basic interest of today's talk. We have nuclear power. We can see that these from the years 1970 until this graph is giving until 2016. From those years, we can see that the usage and the development of nuclear power is increasing and increasing and increasing, because there is a sudden need or a sudden demand in power in our everyday lives. That is another technological breakthrough. And we have mobile phones. No one can argue that mobile phones did not change the way we look at things. We have rockets of human space flights. Recently, we are hearing on the news that say Richard Branson has managed to fly to the edge of to the edge of space, and he is planning to make it like a vacation for everyone to go into space and enjoy themselves, those who have money and so on. We couldn't think about these things if it were not of technology. And then personal computers, a major game changer in the way we handle our lives, from the first biggest computer which weighed tons and tons and tons of kilograms and did few processes per hour, to the small computers, personal computers, which we have now, which can fit inside our pockets, in our bags, and they have enormous computing power to make our lives easier at any time. We have digital media, all the YouTube, the Twitter, LinkedIn, Facebook, and all this, which is now removing all the boundaries from who you are, where you are, what you are. We are all being put in the same space because of this digital media. It doesn't matter where you are. Like today, I'm talking to you. I'm in Malaysia. The rest of us are in India. I have seen a few people from a few of my friends are from my country, from Zimbabwe. We have Africans. We have people in Saudi Arabia. One or two people from Europe. We are all in the same place, in the same community, because we are using the same digital media platform to communicate. Right. We have genetic engineering, a marvel which was introduced by Watson and Crick in 1953. And it is seen today that 70% of the processed foods contain genetically modified ingredients such as soybeans or corn engineered for higher crop yields. The population of the world is increasing. The land size is stagnant, it's not getting bigger. The fertility of the soil is decreasing, and so on and so forth. There are so many people to feed, but the output cannot be exactly enough to feed everyone if it were not because of technology. So we have this genetic engineering, the food, corn, which was supposed to be grown in 3 or 4 months, can be grown in 1 month, which means people can have 4 or 5 harvests per year and feed the nation because of all this genetic engineering. All right. And then the greatest of them all will be the internet. So the internet has brought in so much dynamic changes in our lives, to such an extent that one thing which God had given to us as something which might be used to differentiate one human being from another that is intelligent, it is almost losing its value among society. Because everything anyone knows, I can know. Before this, I would have traveled to India to give this talk. I would have traveled to UK to meet a certain professor to get some certain knowledge. I would have traveled to a library to sit in front of a desk and read a book. But because of the advent of the internet, I can be anywhere, anytime. I can be with anyone, anytime, and I can get any information which I need anytime. If I get sick, if I get, I have any problem, I want to go somewhere, I've never been there, I would just go to the internet, search for the whatever I am looking for, and everything is covered. So the internet is the ultimate, the ultimate technological advancement of our time, which has happened to us. But now, if we look at all these 10 aspects, all these 10 things which we have looked at, they all come up with a common problem. It's because they are all based on this internet. They are in the cybersphere. And the cybersphere is a hunting ground for those who want to make our lives miserable, not easy. The cyberspace is there to make our lives easy, but as usual, human beings, mankind, we have one or two who are not in favor, or who want to take advantage, or who want to disrupt. Then we have the problem of security when it comes to our lives and our stay on the in the cyberspace. Now, this is what we have, and this is the problem which I have just identified, that is that we have some challenges when it comes to the internet, protecting ourselves while we are on online. The future is even more challenging for us. We are dependent on the internet right now. We are dependent on the internet. Some still have some options. They don't want to be there, to be on the internet, or to use the internet, or to have the internet influence their life. Yes, you can survive to some extent. But as we look at the future holds the biggest challenge when it comes to the security, because in the future, we are faced with all the augmented reality, we are faced with all the artificial intelligence, the artificial intelligent controlled nature of life, self-driving cars, and we will not need to go to the zoo. I will not need to come to your house to have a good time with you. We can meet within the cyberspace, with all the augmented reality, with all the self-driving cars, and self-flying planes, and everything. Our life is going to be totally changed. But the exposure, the risk exposure becomes bigger and more dangerous, as we can see that within the information technology, which is the driver to the future, information itself can be tampered with. People can tamper with the information which controls your self-driving car if they have the knowledge to enter and control that. People can tamper with your information providers at home, maybe your television, maybe your 3D viewing glasses, or whatever you have, which is connected to the internet. People can go in, hack, and change the information, give you the wrong information, or worse, even do the worst, make that information take away the lives of people in there, which is being controlled by the technological things or the technological advancements which we have just spoken about. So that brings us to the role of information technology in our life. What are the important features of information technology? Information technology has got the ability to flex time. That is one of the powerful things we have in information technology. Actually, when we look at it, why is our lives better today? It's because we have a lot of time to do things which we could not do before because of information technology. We have 24 hours in a day, be it you are in Malaysia, you are in India, you are in UK, your day is 24 hours. Be it you are rich, you are poor, you are African, you are European, you are what religion, it does not matter. Time is exactly the same. Everyone has got time. But technology, it enables us to buy more time. Within the fixed time, we can buy more time by doing more things at any one given time. That is where technology comes in, where technology makes a difference. We used to travel 3-4 days connecting flights and all this from Africa to Asia. Today, because of technology, you can fly into Asia and fly back to Africa the same day. Come in for a meeting, have a meeting in Asia and fly back because of technology. Or worse still, you don't need to use all those hours you have been using to fly, to go to meetings and conferences, whatever. But just stay within the comfort of your house, and technology is giving you all those times you were supposed to be flying. Maybe you are now mending your garden or playing with your kids. When the meeting times comes, you just go to the internet and you connect. So we have bought the time which has been lost before. We look from all angles and all aspects of time. The main idea, the main advantage of technology is the ability to flex time, but it comes with a cost because technology can be tampered with, and technology can give even more harmful or negative effects. The other biggest advantage which comes with information technology is the removal of boundaries. There is no longer your space, there is no longer their space, and there are no longer things like physical boundaries, fences, and all those things. There is no longer things like country boundaries and all this. I can have a chat with anyone who is anywhere in the world. I can access whatever I want from anywhere in the world. So the boundaries, the physical boundaries, have been made useless because of the technology. Now, if we look at the removal of boundaries, it is very necessary for us to have boundaries in our own spaces, be it we are in the cyberspace or we are in physical spaces. But in cyberspace, the concept of boundaries has been eliminated, and eliminating boundaries brings in a lot of problems when it comes to the cyberspace. Self-empowerment. Technology allows us to be self-empowered, and the self-empowerment has changed the way we look at things, the way we do things, the way we think. We no longer have an African mentality. We no longer have a European mentality. We are all one and the same thing, psychologically, sociologically, mentally. We are all moving into be one and the same thing. Whatever you do, whatever you see, whatever you like, whatever you enjoy, it has been made available to almost everyone now because of the advances in technology. All right. So the other thing which has been brought in by the advances in technology, I talked about industry 4.0. It is this Industry 4.0 and the 9 pillars which support it, which is autonomous robots, big data analytics, supply chain, additive manufacturing, cloud computing, cybersecurity, industrial, Internet of Things, horizontal and vertical integration, simulation, and augmented reality. So these are the 9 pillars of technological advancement. All these 9 pillars are being attacked today by the cyber issues in cyber security, the cyberspace related issues. This is the greatest threat which is being faced when it comes to the Industrial Revolution 4.0. So we have to set the cyberspace in the correct context, and we have to provide the very best of the protection to all the cyberspace players, so that being in the cyberspace will be a comfort zone, not a zone where we cannot go in because of fear of being attacked, fear of losing our information, fear of being manipulated, and fear of being terrorized. So we see that when we are talking of cloud computing, the biggest threat on cloud computing, it has got its own very marvelous advantages, but the threat of security makes cloud computing a very, very challenging pillar for Industrial Revolution 4.0. All right. We look at supply chain. We look at even big data analytics. We look at autonomous robots. They can be attacked. The way they react, the way they process can be changed by the attackers remotely and without even noticing it. And those changes, in most cases, will be catastrophic changes. All right. So we have to have a very strong sense of security. We have to have a very big, a very diversified, a very robust security system to look at and protect the information and the service providers which are based on the technologies which reside within the cyberspace. So for the security, we have to look at security for the cyberspace security. We have to look at security for the devices within the cyberspace. We have to look at the network as a whole security. We have to look at computer security. We have to look at data security. All right. So the main talk of today is based on the challenges on information security. How and what are the challenges we are facing or we expect to face within the security challenges we expect to face within the realm of information, especially these days where we have information being scattered around within the cloud. So the threat, the biggest threat is on cybersecurity and information security. So information security and cybersecurity might be viewed as one and the same thing. It is very difficult to differentiate between cybersecurity and information security. And because of these challenges in differentiating or in identifying these two, it also poses a lot of challenges in coming up with proper solutions. Basically, when we're looking at cybersecurity is meant to protect attacks in the cyberspace, such as data, storage sources, and devices. So our data, our storage sources, and our devices, they are all coming under the protection or the definition of cybersecurity when we are looking at the security of those things. But when we look at information security, in contrast, it is intended to protect data from any form of threat, regardless of being analog or digital. And cybersecurity usually deals with cyber crimes, cyber frauds, and law enforcement. So there is a thin line between cybersecurity and information security. Information security in wholesome, it refers to the processes and the methodologies which are designed and implemented to protect print, electronic, or any form of confidential, private, and sensitive information. That is information security. We are protecting the print information, the electronic information, or any form of confidential, private, and sensitive information. We are looking specifically at the processes and the methodologies of giving protection to this. So that is information security. When we're talking of cybersecurity, we are looking at the bigger picture. We are looking even at the devices. We're not looking only at what is inside the devices, what is inside the storage sources. We are looking at the storage source itself. So it might also include some form of physical protection and also some form of protection which might not be physical. And the main aim of information security is to protect from unauthorized access, use, misuse, disclosure, destruction, modification, or disruption. That gives the importance of information security, because where the security is lacking in terms of information, the challenge is people might have unauthorized access and misuse that information. They can disclose information which is not supposed to be disclosed. They might even destroy information when it comes maybe to law, judiciary system. There is evidence which is there. If I manage to get hold of that evidence, if it is in the form of information, I can destroy it, or I can modify it, or I can disrupt the services which are being served by that form of information. So information security is of uttermost importance when we are in the cyber realm, when we are in the cyberspace, especially with the advent of cloud storage and everything, where we cannot put physical security, we cannot have well-defined boundaries to the users of information in a given space and time. Right. Like I said, there continues to be a very big debate whether cyber security and information security mean one and the same thing. So in this context, it makes sense to look at cybersecurity as a form of information security. So cybersecurity is a form of information security. When we are saying that information security is the wholesome, is the wholesome thing, we are looking at protecting information security, and by having some form of some cyber security, we are having some protection of some information. So cyber security is a form of information security. All right, and then we can look at information security as an umbrella with cyber security and other security topics like cryptography, mobile computing within it. So information security is the umbrella term when it comes to all these forms of security. When we are looking at information security, there are quite a number of threats which are out there, which can threats and attacks, which are always imminent, which are brought in by some policies, which are brought in by the environment, which are brought in by lack of knowledge, and so on and so forth. So I have taken the liberty of listing some of the most imminent attacks when it comes to information security. We have ransomware attacks, IoT attacks, cloud attacks, phishing attacks, blockchain and cryptocurrency attacks, software vulnerability attacks, machine learning and artificial intelligence-based attacks, and bring your own device policy-based attacks. So these kind of attacks, they are extremely difficult to fight against if we are looking at the internet or the cyberspace, because the issue of boundaries has already been removed, like I have said before. So when we do not have boundaries, it is not easy for us to determine what goes in and what goes out. First of all, it is almost impossible for us to determine what is inside and what is outside if there is no boundary. We need some boundaries of some sort for us to be able to determine what is inside and what is outside. So with traditional, I will be looking at traditional networks and the current networks. With traditional networks, it was quite easy because traditional networks were based on the theory of having boundaries. But today we do not have boundaries because of policies like bring your own devices, work from home policies, where you are supposed to access information, access resources within an organization from outside an organization, something like that. So the boundary between you and the organization has been removed. So to put those boundary-based policies, which will help us to eliminate the threats on the pretext of being from within or from outside, it is no longer possible. What are the goals for information security? What are the goals for this information security? So the goals for information security are many, but the three most basic goals are confidentiality, integrity, and availability. When we are talking of information security, when we are researching on information security, when we are providing solutions for information security, we are basically trying to address the issues of confidentiality of information, integrity of information, and availability of information above all the above everything. All right. So to address confidentiality and address integrity and address availability as individual components of information security, it is a wrong approach. We have to address these three different components in wholesome as one goal. Our goal is CIA. It is not C, it is not I, it is not A, but it is CIA. All right. I just talked of the relationship between information security and cybersecurity. So when we are looking at confidentiality, integrity, and availability of information, that it has always to be there. We have to meet these goals. We have to look at the types of security which we have: information security, cyber security, and network security. If we provide information security, it means that we have covered the needs for cybersecurity, and we have covered the needs for network security, because they are all, cybersecurity and network security are subsets of information security. So our biggest challenge is information security. All right. To provide this, I talk about the issue of boundaries when it comes to provision of when it comes to provision of security in the cyberspace for information, be it for whatever kind of security we want to provide. It has to have some boundaries first to define it. This was the concept which has always been there. But if we look at today's networks, today we have what are called software-defined networks. And there is a very big difference between today's networks and the traditional networks. With traditional networks, it was quite very easy. Why? Because traditional networks, as I have said, they have been based on boundaries. When you have a boundary, a perimeter boundary or a security boundary, be it we're looking at it from the technology point of view or from another point of view, you can define an entry and an exit point. Even when we are looking at our house, normally we put a perimeter fence, and then we will put some measures that if someone enters through a point which is not designated, then that person is an adversary, or that person is a thief, or an uninvited guest, or whatever. Same applies to the traditional networks. Traditional networks are usually hardware-based, right? The most notable difference between software-defined networks and traditional networks is that software-defined networks are software-based. They are based on software. So they do not have hard boundaries. They are a set of rules and regulations, instructions, which are put in together to cover a very wide perspective or a very broad domain of security, eliminating the need of boundaries. At the same time, traditional networks, they are usually hardware-based, as I have said before. So traditional networks, they use switches, routers, and other physical infrastructure to create connections and run the network. So we would go to our switches, intelligent switches, layer 3 switches, layer 2 switches, and our routers and all the other networking devices, which we will put at our gateways. We will put the instructions within those routers and switches that this information cannot go out, this information cannot go in. Why? Because we have a complete definition of what is the definition of inside and what is the definition of outside. That is in traditional networks. But now in modern day networks, we do not have inside, we do not have outside, because you can still access your institution, you can still access your organization when you are outside the organization. You can behave as if you are within the organization. All right. And more so, the attacks which are facing the information these days, they normally do not respect boundaries, because these attacks are neither residing within the network or outside the network. They are not within an institution or within a device, or they are everywhere. They are omnipresent everywhere. We can put the boundaries. We can put a firewall that anyone who is outside this firewall cannot enter in and access our servers. But the person within the institute themselves, they have the access to those servers, and they are the most dangerous people. So they do not need to be checked by the firewalls. They do not need to be checked by the routers, which are protecting the the area from outside. All right. So that gives us a big difference between traditional and modern day networks and the challenges which we are facing. So we are beginning to see the challenges which the information security is facing today compared to the traditional networks. So while the traditional environment controls access through a perimeter security model, a cloud environment is thoroughly connected, which facilitates the traffic for bypassing traditional perimeter defenses. Because everything now is based on the cloud, on cloud computing, our servers, they are accessed through the software-defined softwares. We have the databases in the cloud. We have all the information residing within the cloud, and the cloud can be accessed from within or outside a traditional perimeter defense. So that makes all the traditional or all the security models which we used to have be not applicable to most of today's security needs. We used to define our networks in mainly 4 different types, where we have the local network, which is smaller, easier to manage, well-defined boundaries, and we can manage each and every node by node, and the network as a network as it is. And the networks would grow and grow and grow from personal area networks to local area networks to metropolitan area networks to wide area networks, which is the internet. So this idea of computer networks, defining them in terms of the size and giving the boundaries in terms of functions and the size, they were used to create the security perimeter. Right. So creating a security perimeter can be defined as placing the necessary safeguards at the entrance of a privately owned network to secure it from the hackers. So on the entrance, we define the perimeter and we define an entrance. So we put some security measures within the entrance. So the hackers or the adversaries, they will not be able to enter into our network. Quite easy, very, very easy those days. Because the network perimeter security was an essential element for any modern business whose network has access to the internet and the World Wide Web. So network security perimeter is an essential element. But how can we put a perimeter? How can we put a boundary where we do not have rules, we do not have regulations, we do not have definitions, we do not have limitations? It's impossible. It's almost impossible. So this perimeter-based security, is it really enough? No, it is not enough, because there are a lot of elements which are being introduced by today's networks, which really disrespect the elements of perimeter-based security. As a result, we are now being faced with a new phenomenon of looking, or a new phenomenon or a new perspective of looking at security. The element of trust is no longer there, because we used to trust the users. We used to trust the definitions which we give, because we had pure and proper definitions based on the boundaries. You come in, you give the credentials which allows you to get the information. They are checked at the entry point. If you have those credentials, then you enter there, right? But now the element of trust is no longer there. There is now zero trust. Now, our networks, they cannot be dependent on the trust that everyone who is passing through an authorized entry is an authenticated or an authorized user, because networks can be attacked by users. Networks can be attacked through devices. Networks can be attacked through applications. Networks can be attacked through the data itself. And the network can be attacked through the traffic, which is generated by that network. And network can also be attacked through the workloads. So you have to eliminate, we now have to eliminate the element of trust within all these players within a network for us to provide a proper information security. And eliminating that trust is a big challenge. That is a challenge which we are facing today. What brings that element of trust to be taken away? Because we cannot be put into the same working sphere as we used to be. We used to go to our office and access the information through well-defined entry points, the computers which are well protected, which have got passwords which are protected, limited by the organizational policies and so on and so forth. But when it comes to this era where we are working from home, the era of cloud computing, the era of mobile devices and Internet of Things, the network security perimeter is gradually disintegrating. That perimeter is disintegrating. It's going away. And internal and external threats are intensifying. Before this, we could manage internal threats as a set of threats. We could manage external threats as a set of threats. We have policies, we have solutions to eliminate external threats. We have policies to eliminate internal threats. But if we do not know now what is an internal threat or what is an external threat, then we can no longer use those policies. We can no longer use hardware-based policies or software-based policies which are put at the gateways of our networks, because they are disintegrating. The walls are falling down, and the gate or the entrance into our networks, the entrance to our information, to our data, is becoming wide and wide each and every day. So therefore, there is need for software-defined perimeter. And the need is getting bigger and bigger, and the user-based zero-trust network security architecture is required to support the new security model. This is the new research area which security is moving towards, the zero-trust security models, where the network does not need to trust anything. It doesn't trust itself, the network. It doesn't trust the users. You might be the owner of the network, but the network does not trust you. You have to prove yourself beyond doubt to the network that you are the authorized user from wherever you are. You don't need to be, there is no difference between you being in the office and you being on a flight or on a train for you to be able to access the information which is residing within the servers of your organization. Those boundaries are taken away already because we are now working from home, because it is now cloud computing. Cloud computing does not know whether, does not need you to be at a specific fixed space for you to be able to access the resources, right? So why do we need to move to software? Why do we need to move to these software-defined perimeters? Why do we need to move to software-defined perimeters and zero-trust networks? It's because the current hardware-based security perimeters, along with the notion that the notion and the assumption that the threats are being outside, the threats are always outside, and the safe zone is always within the inside, is completely inadequate to secure companies today. It's no longer that, because we no longer have the inside and the outside. There is no difference between you being inside or you being outside in the cybersphere, all right? So this is because of two things, because of everything has moved onto cloud. Those days I used to move around with a bag, with my external hard disk, with my pen drives, with my floppy disk. For those who have survived in the era of floppy disk, we used to have those. If you are going to have a presentation, you forget a floppy disk, then you will have to drive back home just to take that small black thing which contained your information. But that gave the boundaries. That if you do not have the floppy disk and you do not insert the floppy disk within a certain computer which has got a certain antivirus to check whether that information is good for the system or not, then you wouldn't have access, because that was kind of a boundary, a hard boundary, a hard boundary there. But now everything is based on cloud. Be it I am wherever I am, I just need myself and access to the internet, and everything I need, I can get it. I don't even need to carry my computer around with me. I can use anyone's computer to get my information. I don't need to install softwares. I don't need special hardware, because everything is on the cloud. So that is the biggest reason why we have to move today from the traditional networks to the new platforms and zero trust networks. All right. The second reason is security focused on devices or IP addresses instead of users won't work. We can no longer use IP addresses. We can no longer use devices to discriminate who accesses information and who does not access information. IP addresses are dynamic. Within the same network, within the same area, within the same organization, you can have dynamic IP addresses as you move around, working from one desk to another, from one point to another. You are connected to different access points. Your IP addresses are changing and so on. So it's no longer about IP addresses. No, it won't work. It's no longer about devices. No, it won't work, because I can use any device anywhere to access anything I want to access from anywhere. So in today's environment, where everyone works on multiple devices, spending large amounts of time outside your network, it is impossible to have these hardware-based security perimeters. That is the biggest challenge we have in information security today. So as we move on to the cloud platform, we are faced with a lot of threats, new threats, a lot of threats which affects us every day. As we can see, everyone is working from home. An office is no longer an office today. It's just an empty desk with an empty chair. And my office is now everywhere. My office is a seat on the train. My office is a table in the restaurant. My office is my dining table at home. My office is everywhere. So a lot has changed in our corporate environments, necessitating a change in our security. So virtually everything is moving to cloud. with users using multiple devices as they work. How can you visualize, how can you control, and how can you secure a distributed cloud-based environment with a hardware security perimeter alone? It can't be done. So the challenge is we can no longer depend, I keep on repeating this, we can no longer depend on hardware. We no longer depend on the perimeter to be the basis of our security. Why? Because people are working from multiple devices, work PC, home PC, laptops, iPads, phones, watches. You can read, you can answer your handphone using your phone, your watch. You can change the music, you can connect to different devices using Bluetooth with your phone. So as long as that there is that link, that connection between device and device, that is an opening, that is a gap which needs to be tightly monitored so that the information which is coming in from my watch to your phone is authenticated information, so on and so forth. So this opens a lot of attack surfaces because we have so many different variety of access to devices which reside our information or which provide information to us. We have so many attack surfaces because we work from a lot of multiple devices. Working from home, this has been the biggest game changer for the past 2 years because of this COVID scenario. Everyone is now, almost everyone is required to work from home, learn from home, teach from home, and do everything from home. We shop from home, be it food, be it clothes. We learn, be it practical classes, be it theoretical classes. We are teaching from home. We are doing our administration work from home. And for this to be able to be done, for us to be able to access and deliver through the networks, through the internet, it means that everything we are dealing with, it has to be converted into some form of some information delivered through the internet to the rightful persons or the rightful users. Now, who is the rightful user and who is not the rightful user? If everyone can access the information, that is the biggest challenge we have today. So we also have our servers in public cloud and data centers. I just know that I need to upload my pictures. I need to upload my research work. I need to upload. Who is taking care of it in the cloud and everything? It's all based on trust that the third party who is looking at the storage of my information, the security of my information are trusted people. So that is another challenge. Then we have third-party cloud applications, mobile devices, IoT devices, work on the road, which has been necessitated by this work from home and zero boundary workspaces. Then it brings in a lot of attack surfaces. So if you look at the picture which I have put here, we have so many attack surfaces which is attacking our data on the cloud. And we cannot say this is the boundary. We cannot say we have the boundaries between these kinds of devices and the sources of information. All right. So the software-defined perimeters for a cloud is for a cloud-enabled world. This really, the software-defined perimeters, depending or relying very much on the concept of zero trust security, has enabled us to work within this challenging sphere of cloud computing. The challenges are to build, to support the cloud, to make it scalable, and utilize a zero trust architecture. So I'm working on a lot of research recently with a few of my students, based on this zero trust architecture and so on and so forth. And to be honest, it is a very challenging sphere of research, because there are no rules, there are no guidelines, there are no limitations in terms of anything. Scalability, it can be small, it can be as big. The trust, who do you trust? How do you measure the trust? How do you give the authority? How do you limit what you cannot see, what you cannot control? It is very, very challenging. So zero trust networks are defined generally as networks where no person or device or application should be trusted by default. This is the way forward. You don't need to trust any device. You don't need to trust any application. You do not need to trust any person. Provide such a solution, then it is the ultimate solution, right? So the trust should be based upon the user and the privileges you are assigned, and those privileges travel with you wherever you go. The privileges which are given to you by the network or the service provider, they go with you wherever you go. That's why these days it is very possible for you to access your resources from wherever you are. The zero trust network is already taking control. The concept is already taking control. It is a very broad statement covering all network traffic, servers, users, applications, and devices. And the benefits of this zero trust security are: number one, zero trust. Trust no one, trust nothing, and don't expect to be trusted, even you are a device, you are a user, or whatever. So there is no trust. The element of trust has been taken and has been thrown away. And then there is micro-segmentation of resources, of access, of everything. Everything is segmented into very, very smallest possible segmentations, so that if any fault or any weakness of any segment is harvested by the attackers or the hackers, whatever, it will not affect a bigger portion. All right. So before this, we're looking at networks as security for a wholesome network. So if you manage to breach the entrance into a network, you can have access to all the information and all the data. But in the zero trust security, these privileges are segmented to such an extent that you can breach one segment, but from that segment, you cannot move on to another segment, which means the damage will be minimized. So zero trust security also enables entire network visibility. It enables scalability, security communication, invisibility if you need it, and also it enables control. So there are so many solutions which are available to secure the information from within the organization, from outside the organization, especially in the era of cloud computing. So some of the few which I have managed to put in here are home office security. Because we are working from home, we need to have that kind of security, home office security. You must have antiviruses on your devices. You must have some good, if you have information residing on your devices, you must have some good authentication to the devices which you have. That gives us the second solution, which is multi-factor authentication. Don't rely anymore on passwords. Passwords can be cracked. You can be social engineered to give away your password without knowing that you are giving away your password. And it is very difficult also to keep track of one authentication factor, whether it has been attacked or not. It is very difficult. Let's say your password has been attacked, it has been it has been given out, it will take you maybe years for you to know unless you change your password regularly. So the advent of multi-factor authentication as a solution to information security is also very good, especially when we use biometrics and things which are on us, things which define us as voice, fingerprints, our eye scanners, so on and so forth. Then we have cloud application security, we have secure communications, we have data security, that is a good encryption of data security. We have backup and disaster recovery solutions. These are also very, very important. And then we have securing and monitoring, which is extremely important these days, where we have SIEM, Security Information Event Management, and managed detection and response, MDR. Why would you need managed detection and response? It's because now we are all working in the same sphere. It's no longer an era where we have a security specialist to protect everyone within the company. Every person within an organization is now an important part of information security. That is a big challenge. But when it comes to that, not all of us are trained well enough to be able to provide that kind of security to the information. So managed detection and response, these are software-based solutions which will do the job of managing the detection and responding to attacks. Why do we need that? Because they deliver the most complete security for your company. You don't have to, you do not need enough trained personnel. So if you do not have enough trained personnel, you need all this managed detection response. And most organizations, they do not have. Universities, companies, so on and so forth, they do not have. So we need something to help us to take care of our security needs. If your security team are not experts on managing and detecting and how to integrate the right security products, you need the MDR. You need MDR services if you do not have a team of experts. And if you would rather have your team to work on revenue generating projects. So when we go to work, when we are using internet-based resources, when we are accessing the information in our work, like in education, we are accessing the information in all these. The information is the end product. What am I here to do? We are here to teach the students and in most cases, generate some revenue. So my job is not really to look at the security of the information. For me, that would be secondary. The primary job will be to maybe generate revenue if I'm working in industry. So why would I put so much emphasis on managing and detecting the security breaches within within my organization? No, I will not do that. So if we have such a situation, this is a right platform for us to deploy the managed detection and response mechanisms. All right. And then it saves money. It saves money. You don't need to train everyone. You do not need to hire experts. You do not need to monitor yourself, and you do not need to analyze yourself the network performance and all this. All right. Okay. So I have covered from the general perspective what is the gap, what are we facing, what are the advantages of technology, where is technology taking us these days, what are the needs when it comes to technology these days, and what is the greatest challenge we are facing today when it comes to information security. So I have also tried to give him some general solutions for securing the information within our organizations. So this talk has been more of a general talk, not a technical talk. If given another chance in another platform or another session, I would love to come and give a more technical talk on how really do we then manage the information system within the networks, giving some practical examples and giving some tips and ways of how to do it. So today we just looked at the challenges and maybe the solutions we have today as a result of advances in technology and advances in information use and diversification of the use of information around us. From Infrastructure University Kuala Lumpur, I would like to thank you also very much for listening, and I hope I did not manage to make you sleep, and maybe most probably you have gained one or two things from my talk. At the same time, I wish to thank SRM Institute of Science and Technology for giving us this opportunity. Our university, Infrastructure University Kuala Lumpur, is one of the best universities in Malaysia, and we in the Faculty of Engineering, Science and Technology, where I am, we have opportunities for research, especially in networking and networking related issues and problems. I would like to welcome all the faculty members who are here from different universities, different places, and all the students who are working on different kinds of research to contact us, come on board with us, and we can share our research and our work together and move forward as a family. I thank you, and I hand over my session to the chairperson. Thank you very much.
Thank you so much, sir, for such a wonderful and informative session on information security challenge in the era of open network and IoT. Surely we will accept your invitation and we'll forward it to our management also, sir. We will plan for one more event, which is a purely technical session, which will be really helpful for us, sir.
Thank you very much.
Okay, sir. A gentle reminder to all the participants, kindly fill in the feedback link that has been posted in the chat box. And also you can submit your questions in the chat box or unmute yourself and ask your queries.
Sudha madam, good morning, ma'am.
Good morning, sir. Participants, you can unmute yourself, and if you have any queries, you can ask.
Hello, sir.
Yes, hello,
sir,
yes.
Sir, I'm Mohidul, sir, your student, IOKL.
Oh, yes, hello, Mofijil, how are you?
So nice to hear you, sir. Very good session and very informative to hear you, sir.
Thank you.
Thank you so much, sir.
Thank you very much. Thank you for joining us. Thank you very much, Mofijil.
Okay.
Yes.
Nice to see you, sir.
All right, yes, remember to fill in the forms. For all those who have attended, I have been informed that you will be given a certificate or an acknowledgement for attending. So please give in your information now.
Yes, sir. I attend all the session last 7 days.
Wonderful. Thank you very much.
Thank you, sir. Thank you so much.
Sir, there is a question posted in the chat box. So please explain about software defined privacy.
Professor, are you there?
The question is posted by Bharanidharan. The question is, please explain about software-defined privacy.
Ma'am, I think he is not able to.
Uh,
Okay.
Sir, you are not audible, sir.
All right, sorry about that. All right, so let's look at it from this perspective. When we are talking of privacy, in the house, the purpose of a house is to give us some privacy. We put the walls, we put the roof, we have the windows for security reasons and mostly for privacy. Even within the house itself, if we look at the analog from the house itself, when we have the washroom, there is privacy, which means there is a door which can be locked. People cannot see you from inside and from outside. That is a privacy. We are putting in some physical boundaries so that what I do not want to be seen or to be known by unauthorized people, they cannot be done. It has always been very easy when we look at privacy from the physical perspective. Now, when we are looking at software-defined privacy, we are now saying we do not have the physical elements. We don't have the physical elements which can define the privacy. But we teach the machine, we teach the computers that if a certain event happens, then activate activity A or B or C, or allow the person or the machine which has given that event the authority or the privilege to have access to the resources. So the main player now here is no longer the physical realm or the human being. It's now all being determined by a software. We teach a software to follow a certain given guideline or rules, that if those set of rules are not satisfied, then there is no access which is given. But if the rules are satisfied, then the access can be given. So that is mostly on the software-defined privacy. It goes also to the software, anything which starts with software defined. We are removing the physical elements, we are removing the human touch, we are putting in software to be in control and to give the requester the requests to give authority to the people who are requesting whatever they are requesting. Okay, so for software-defined privacy, we are eliminating the human being element, the physical element. We are, instead of putting the walls there, we are putting in a software that if an event A happens, then close the curtains, something like that. So that is software-defined software. That's the easiest way I can explain software-defined software. All right.
Thank you, doctor. Thank you.
Wonderful. Okay.
Thank you, sir. Now I would like to invite Mr. N. Krishnamurthy, Assistant Professor, MCA, to propose the vote of thanks.
Thank you, madam. Am I audible?
Yes, sir, you are audible.
Yeah, good morning, everyone and all gathered here for this 2 weeks online international FDP. Today we are finishing the day 7 section. I thank on behalf of the department the chief guest of today's function, Dr. Tadeva Elisha, for accepting our invitation and presenting a wonderful lecture in the topic. Sir, it is a clear-cut idea which you have given will definitely help the research scholars and faculty members to carry out the research. You kept the audience spellbound. And I would like to mention one more thing for the participants, that the Infrastructure University Kuala Lumpur and the SRM has been jointly doing lot of activities. In 2020 December, we had a guest lecture, and in next month we are going to have an international conference that is going to be held on August 18. So IUKL and SRMIST have been doing a lot of activities for the research scholars and faculty members. Thank you, Chief Guest, for your wonderful lecture. I also thank the management for permitting us to conduct events for the improvement of faculty members and research scholars. I thank our dynamic head of the department, Vice Principal Admin, Dr. Dileepan, for arranging this program and making a lot of activities for the benefit of the scholars. I thank the faculty members of our departments and all the participants who have joined for this program and making this as a grand success. Thank you all. Dr. Tadeva, definitely we will have a separate section with technical stuff, so that you can take up and explain a research area that will be useful for all the participants. Thank you all.
You're most welcome. Okay, all right. Okay.
Thank you, sir, for joining us.
Okay, you're most welcome, ma'am. You are very much welcome. Yes.
Thank you, sir.
All right.
Bye, sir. Bye. Dear participants, tomorrow's session will be starting around 9:30 a.m. The session is conducted by Ms. Anuyogam Venkatraman, Enterprise Customer Data Specialist, Google Canada. And the topic is Visual Inspection AI. So kindly join for tomorrow's session. We'll meet around 9:30. Thank you, participants. You can fill in the feedback link posted in the chat box. Thank you.
Okay.
Thank you, sir.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir. Thank you.
Thank you.
Thank you, ma'am.
Thank you, sir.
Hello.
Tell me, sir.
Yes, thank you very much for having me here. I hope to see you again in the next remaining lectures. Thank
Sure,
you so
sir.
much. All right,
Sir.
okay, thank you very
Thank you,
much.
sir. Take
All
care.
right, okay, all right, okay, bye-bye. All right.
Bye, sir.